We have discussed about geometric distribution, how to calculate mean, variance, and also we have studied one important topic of geometric distribution, that is lack of memory property, which is a unique feature, unique characteristic of geometric distribution. In case of discrete distributions, this is the only distribution which satisfies lack of memory property. Today, we will try to see the rest part of the geometric distribution. Distribution function of geometric random variable. Let capital X follows geometric with parameter P, then distribution function of capital X is obtained as below. So this is your definition of capital F, that is called as distribution function. Sometimes it is also named as cumulative probability distribution. Capital F at point T is equal to probability of variable under study less than equal to given point T. So we write this probability. This is the event under study, random variable taking values equal to T or less than T. So this is equivalent to say like this. It is nothing but summation X start from 0 to T. That means I study type 1 geometric distribution when it starts from 0 into inside summation the function of geometry P q raised to X. Now we have to simplify this, and that would be the answer. P is a constant taken out, summation X 0 to T q raised to X. Now I will expand this summation by putting particular values of X. X is 0, anything power 0 is 1, plus, that means sigma. Next value of X is 1, so you get Q. Next value of X is 2, you get Q square, and this method continue, plus, lastly, plus X equal to T, you get Q raised to T. So this is called as a finite geometric series. And from your 12th, 11th mathematics, you know the formula of this. The result says like this: 1 plus x square plus x cube plus dot dot plus x raised to n. This is a finite geometric series. The sum of these terms are 1 minus x raised to n plus 1 divided by 1 minus x. There is a condition on the common ratio x, that is absolute value of x should be less than 1. Then this result is true. Now I apply this to our curly bracket. If you compare curly bracket with the result, easily you can trace x is q. So replace x as a q, you get answer of your curly bracket. So capital F at point T, P bracket 1 minus q raised to T plus 1 divided by 1 minus q, and 1 minus q is nothing but P, so that get cancelled. So you get distribution function of geometric random variable whose values begin from 0 to infinity. So this is the result of distribution function, 1 minus q raised to T plus 1. This function can be used to calculate a probability of less than equal to type. So any probability which is in this form, directly you can get the answer of corresponding probability with the help of this formula. Now we proceed New topic, MGF, moment generating function of geometric distribution. Let X follow geometric with parameter P, then its MGF is obtained as below. This is the symbol to indicate MGF. By definition, it is expected value small e to the power small t multiply capital X. So this should be capital X. Always remember, inside expectation, random variables should be written capital. Now, how to write expectation? I told before, E replaced by summation. What is inside expectation? It may be anything. Replace that as it is inside summation. And always multiply probability function. So this is the way of writing expectation of function of random variable. Now we want to apply this for a geometric. So summation x from 0 to infinity, e raised to tx, p q raised to x, p constant taken out, q raised to x. So you have summation x from 0 to infinity. This can be written in this way. Power is common, so combine the base. And now expand this by taking separate value of x from 0 to infinity. So you get like this in finite series. So we write MGF equal to P curly bracket 1 upon 1 minus x, that means this bracket. So finally MXT equal P divided by 1 minus Q time e raised to T. I think we have done this in previous lecture. We derived MGF, and by using MGF we tried to get first raw moment. This everything I did in your last lecture. We got variance also in that lecture. So this everything is finished from my side. You can go through again. If you have any doubt, you can ask. Now let us see how to develop cumulant generating function, CGF of geometric distribution. X follow geometric with parameter P, then CGF of capital X is obtained by using definition KXT. It is the notation of CGF log to the base E MXT. Log to the base E, this is the expression of MGF of geometric. I took this numerator to denominator, so I write like this. Now I made a separate division, and then I take the numerator with negative power. And we know that when there is a log, power become multiplied, log to the base E, 1 by P minus Q by P. And these are the bracket. Again, I think this is also explained by me by log series last time. These all things are finished from my side. We got K1, K2, and with the help of that, we can get K3 and K4. So these are, we did it last time. Now we take an example based on geometric random variable. A personal officer knows that 20% of the applicants for a certain position are suitable for the job. What is the probability that fifth person interviewed will be the first one who is suitable? Now such type of question may comes in MCQ. and they will ask, select the proper MCQ for the probability. Now at the beginning, why this question belong to geometry? That is to be remembered. Just like if a question of probability and the information is for average outcome, then you apply Poisson distribution. Now what is the clue for geometry? If you are conducting experiment until you to get a success, then that is the situation of geometry. Now here easily you can see the experiment is to carry out the interview, and when you will stop your interview if you get the suitable candidate. So experiment is continued till to search a suitable candidate. And once you get a suitable candidate, you will stop the interview. So that is the situation of geometry. What this first sentence tells you, it gives the information from these two up to here. It gives the information what is happening in the population. The sentence says that 20% of the applicant are suitable for the job. So if you search 100 people, then out of 100, on an average, 20% in applicants, persons are suitable for the job. That is given information. So this is nothing but your chance of getting a success in the survey. So I will apply geometry to solve such problem. Let X equal number of trials, that means number of interviewed to get first success. Now when I define X as a trial, it begins from 1. And if you define number of failure to get first success, then X will begin from 0. You can solve this problem by both ways. You can define number of failure or you can define number of trials. Both ways provide the same answer. Therefore, X follows geometric with P, having PMF, Px equal, this X should be small, P time Q raised to X minus 1. If variable start from 1, power is X minus 1. If variable start from 0, power is alone X. That is to be remembered. So X takes value 1, 2, 3 up to infinity. P is a probability strictly greater than 0, less than 1. Q is 1 minus P. What is P? What is Q? You have to define. P equal probability, that means chance to get a success in a process. And that is given to be 20% of the population is satisfying your need. So out of 100, 20 people are suitable for the job. That is the information. So chance of getting suitable candidate is 0.20. Q is opposite, not suitable. That is a failure. And that is 1 minus P, 0.80. Hence, the function under study is Px equal 0.2 multiply 0.8 raised to X minus 1. P replaced by 0.2, Q replaced by 0.8. This is the function according to your question. X start from 1 to infinity. What we want? We want probability fifth person interviewed is first one suitable. That means I conducted the interview, first candidate not suitable, then second candidate not suitable, third candidate not suitable, fourth candidate not suitable, fifth candidate is a suitable. So fifth trial is a success, and before fifth, the four trials are failure. That's why it is 0.2 multiply q raised to 4. How this 4 comes? Because previous 4 trials are failures. That's why it is failure chance to the power. Now you simplify by calculator, so this gives required probability. Now you can solve. I told beginning only, this question can be solved by number of trial or can be solved by number of failures. Let us check. So X follow geometric P with PMF, Px equal P time Q raised to X. Now power is X, so X begin from 0 to infinity. Now X stand for number of failures until to get first success. So here also experiment conducted to have a success, and here also conduct the experiment to get a success. But what you are going to record is different. In that random variable, you are recording trial. Now here you are not recording trial, you are recording outcome of the trial, whether that is a failure or success. Chance of getting a success 0.2, chance of getting failure is 0.8. We want probability fifth person interviewed will be the first one suitable. That means just now I told, if fifth is a successful candidate, what are the remaining four? They are failure. So probability X equal to 4. That is the difference between this and this. Here you say X equal to 5 because number of trial. You conduct the interview for 5 peoples. Here you write X equal to 4 because you are observing how many failure before getting a success. So before getting a success, you are having a 4 failure. So I put X equal to 4 and the same answer. So it doesn't matter whether you play with failure or you play with trials. Example 2, if the probability that a certain test yields a positive reaction 0.4, what is the probability that less than 5 negative reactions occur before the first positive one? Again, the question is of geometric type. We are observing the yield of the test. Some tests are giving a positive report, some are giving a negative report. That means when you apply the medicine to certain patient, sometime he or she get a reaction. So reaction may be positive, reaction may be negative. So chance of getting positive reaction is 40%. And we want to get probability to have less than 5 negative reaction before the first positive. So here, this gives a success. So having a positive reaction is a success in your experiment. And if you get a negative reaction, that is a failure in the experiment. So now how to define your X? I define X as number of negative reaction before the first positive. So this is your success and this is a failure. So I define X in terms of failure. We have probability of getting a success 0.4. Define X, Px equal to P times Q raised to X minus 1. X is 1 to infinity. That means this is a function where I play with number of trials. When I write X equal to 1, it is a number of trial. So such that, so this is another question. This I put as a homework. Everybody solve this by using example 1. The rest part I keep as a homework. This is another question. You have function which is a number of trials with this condition. Probability at 4 is given, probability at 3 is given. By using this information, they ask to find probability at 6, mean of X, variance of X. Now, what do you mean by this question? To solve this question, you should have a knowledge of P, knowledge of Q. Just like example 1, example 2, P is provided. But here, P is not provided, probabilities are provided. So by using this information, your first step is to develop value for P. And then ultimately Q is 1 minus P. So I will try to get P first and then I will find the answers of these 3 bits. We have probability at X equal to 4, which is 0.2889. Now function is given in the question. It is not from my side. So I will use this function. Replace X equal to 4. So it is P Q raised to 3 equal to this probability. Now replace X equal to 3. You get PQ square 0.428. Take the ratio of 1 by 2. So PQ raised to 3 divided by PQ square, ratio of this probability. This is simplified. PP get cancels, 2 get cancelled with 3. So you get directly answer for Q. So Q equal to 0.675. Now what is P? P is 1 minus Q. I got P, I got Q, replace in the formula. And once function is known, you can get a probability. So probability X equal to 6 equal P Q raised to 5. Replace the value of P, replace the value of Q and solve by calculator. What is mean of X? Mean of X is not Q by P here. Why not Q by P? Because when X start from 1, mean is 1 by P. And if X start from 0, mean is Q by P. That should be remembered nicely. So for this example, mean is 1 upon P. You have a knowledge of P. Replace here and solve by calculator. Third question, variance for both random variable. Whether it is number of trial or number of failure, variance not change. That is Q by P square. Putting the values and get simplification. Next example is a machine is used to produce milk cans, has a probability 0.04. to produce defective cans. So there is a machine that machine produces milk cans, and it has a probability of defective can 0.04. That means 4% product is defective. Question: find the expected number of good cans produced before the first defective can. That means now here I conduct the experiment, I keep the watch on machine till to get a first defective. And that is the situation of geometric distribution. Bit number 2, fourth can produced is the first defective can. So here you have to find expected number of good cans. So here you have to find mean, and here you have to find probability. That thing should be clear. Let us see how to solve. X equal to number of cans produced before first defective. So it is same as number of trials before getting a first success. Therefore, X follows geometric P with PMF as Px equal P time Q raised to X minus 1, X start from 1 to infinity, otherwise it is 0. If X is not coming from this range, function taken as a 0. Now in this formula, what is P, what is Q, depends on the information. Question says, a machine produces milk can with 4% defective cans. I define X where success is a defective can. So according to this, I decide P. So P is a chance to get a success. Success is a defective can, that is 0.04. Q, opposite of your P. Probability to get a failure 1 minus P, 0.96. Let Y, number of good cans produced before first defective can. So Y equal to X minus 1. Expected value of Y equal to expected value of X minus 1. Take expectation inside Ex minus 1, and X is a number of trials, so mean is 1 by P minus 1. P is 0.04. Simplify, so that is a 24. So what 24 tells you? It says expected number of good cans produced before the first defective can. That means when the production process starts, on an average, 24 cans will be always good. And after 24, there is a possibility to have a defective can. But on an average, first 24 cans always a good can. And that's why it is a clue. You can leave the process independently up to having 24 can. After 24 can, you stop the process, check everything nicely again, raw material, setting of the machine, workers, and so many factors. If all are okay, again start the process. Again you will get 24 good cans. Stop it and recheck and continue like this. So it will help you to produce less number of defectives. What is the second bit? I want probability to have fourth can produce is the first defective. That means I kept the watch on a process. First can is good, second is good, third is good, but fourth result in defective. So chance of getting x equal to 4 is equivalent to say chance of getting 3 defective. So p q raised to 3. Put the value of p 0.04, value of q 0.96, simplify by calculator. So these are the questions, different type of questions related to geometric distribution. This completes your second chapter under the heading of geometric distribution. You can see exercises from the textbook. Also try to solve multiple choice questions